going to talk about parallel lines and their relationship. Remember, the parallel line has many applications in real life. For example, we can identify parallel lines in the transportation, we can identify parallel lines in construction, even in the street or even in civil engineering. So remember, the applications of parallel lines is in everywhere. So you can identify that this topic is so useful in the real life. So here we have some examples of parallel lines cut by a transversal. Remember, these two lines are parallel because we have the same distance and never connecting or never joining, or you can say never intersect. But we have a third line which is called transversal, and with this line we can form some relationship between the parallel lines, like alternate interior angle, alternate exterior angle, corresponding angle, vertical angle, complementary angles, and supplementary angles. In this case, our objective is to identify the value for the variable. And with this value, we are going to identify the value for the angle. Remember, this is called angles because we have the vertex here, angle, this is another angle, this is an angle, and angle. So this is parallel line and their relationships. So here we have 3x plus 13 and 4x minus 10. If you remember, in this relationship we have these two are alternate interior angles, so that means that both are equal. So what do we have to do if you want to identify the value for the x? So we're gonna put an equality, or it's a 3x plus 13 equal 4x minus 10, because remember this and these angles are the same because are alternate interior angle. Then we have to do arrange variables and constants. In this case 3x, and this is positive 4x, we are going to move as a negative 4x using the inverse operation. Then we have negative 10, and remember we keep negative 10 because we arrange in the same position. We don't use the transposition of term, and this is positive 13, so we are going to move as a negative 13. Then we are going to simplify 3 minus 4x, which is negative 1x, equal negative 10 minus 13, which is negative 23. Then we divide this one by negative 1 and this one by negative 1. Remember, we are working with equations, so we need to keep the equality in both sides. So if we divide by negative 1 here, we need to divide by negative 1. Then negative 1 divided by negative 1 is gonna be x, or you can say 1x. And negative 23 divided by negative 1, it's going to be positive 23. So this is going to be the value for the x, but not the value for the angle. So what do we have to do? We need to take one of these angles. In this case, you can take this one or this one. I'm going to take the first one, which is 3x minus 13. And we are going to substitute the value for x, which is 23. So we are going to do like that, right here. It's going to be equal 3, we open parentheses, we put 23 instead of x, minus 13. Then we multiply 3 times 23, which is 69, minus, this is plus 13, this is plus 13. Here we have plus 13. I have a mistake here, it's plus 13, and then 69 plus 13 is gonna be 82. So the angle for this relationship is gonna be 82 degrees. So this is going to be the angle of the relationship between these two parallel lines. And remember, if this angle is 82, this is going to be 82. So you can write here, like, you can put here 82 degrees. We are going to write the angles 82 degrees. And then if this one is 82 degrees, this one is going to be 82 degrees because are alternate interior angles. So we can write here 82 degrees. And we already have the two angles in the relationship. Now with this one we have a different case. As you can see, we can use these two vertical angles because we have a variable x and we have a variable y. And you cannot solve because if you want to solve, you have to have the same variable. So, but here we have this x, and as you can identify, this 17x minus 70 and 2x plus 5 are alternate exterior angle because are outside of the parallel lines. So we are going to use this relationship to work. So it's gonna be 17x minus 70 equal 2x plus 5. Remember, we have the equality because this and this are the same angle. So now what do we have to do? We need to work with equations, with linear equations. So it's gonna be 17x, and this is positive 2x using the transposition of term or the inverse operation. We are going to move as a negative, and then plus 5. Remember, we keep positive because we arrange in the same position, not after the equal sign or before the equal sign. And this is negative, we pass to positive. Then we have 17 minus 2, which is 15x equal 75, because 5 plus 7 is 75. Then remember, if we want to have the equality, because our equation, so we need to divide both sides by 15. So it's going to be 15 divided by 15, it's going to be x, or we can solve the 15 because we have 15 by 15, it's going to be 1. So you can write only x, or you can write 1x. And 75 divided by 15 is going to be 5 degrees. And we already finished with the value for x, but this is not the solution, remember, because we need to find the value for each angle. So what do we have to do? We take this or this value. In this case, I'm going to take 2x plus 5 because it's better to take it. So because it's more easy, it's easier to multiply 2 times 5 than 17 times 5. So in this case, I'm going to take 2x plus 5 degrees. Then we need to substitute this value. How? Like this. 2 multiplied by the value of x, which is 5 degrees, plus 5. 2 plus 5 is 10. 10 plus 5 is equals to 15. So the value for the angle is gonna be 15 degrees. And we already finished with the relationship between the two parallel lines.